Hello everyone, my name is Edgar de los Santos. If you can hear me, can you please press the button with the hand? Thank you so much. In today's session, we're gonna go over the CAD to CAD modeling. We're gonna talk about the pre-modeling using CAD-based programs, and then we're gonna import that geometry from CAD into midas. Then we're gonna start the low definition and application, and then go over a little bit of the construction staging, and then we're gonna end up exporting that CAD back, exporting that model back to the CAD. So in the pre-modeling, and this entire webinar will be talked about the steel composite bridge. This is the bridge information that we're gonna go over. It's a two-span bridge with a total length of 180 feet and a total width of 37 feet. So the entire pre-modeling will be used or will be done in CAD. CAD is an everyday tool, as you might know, and with CAD you will be able to generate the model from the center line, saving a lot of time, and also, generating a model can be very time consuming, so this will actually be a lot of benefit, or will benefit you a lot, in the sense of not having to model element by element. This can be done by the drafters, if in the case that you have any, or you can just bring it from your plans as well. So what we're going to do is let's say if you have a model like this one, in which you generated your plans, and you can just bring the center line for each one of your members. In this case, what we did was we generated a layer for each one of the elements, so that will make it easier for us to import it into midas. We generated blue for the cross frames, green for the dummies, the center in red is gonna be the transverse elements, and we have white for the substructure. If you have drafters, you can tell them to do something like this. It will be very easy for them and will save you a ton of time. So let's say that you have something like this in CAD and you want to bring it into midas. So what we're gonna do is we're gonna open up midas. For those of you who do not know the program, this is the graphical user interface. Through this graphical user interface, you can generate the entire model, but in this case we're gonna save those steps and just bring the AutoCAD. Let's create a new project, and with that new project, what we're gonna do is the first thing is check the units. Let's use kibs, foot, and let's bring in CAD. As you can see here, midas can import different types of files. In this case, we're gonna use the CAD DXF extension, and we're gonna bring a CAD from our documents. And here we have the CO final, which is this model that we have here. It's the center line of this bridge. And what we're going to do is we're gonna bring in members by importing the geometry. So let's say that we bring the transverse elements as the center. We can simply apply, and the program will do something like this. If we bring the cross frames, let's say only bring the cross frames, the program will generate also the cross frames like this one. As you can see, we're saving so much time just in the generation of the geometry. We can bring multiple at the same time. Let's bring in the dummy elements. We can also bring the pier cap and the pier, or we can bring multiple layers at the same time, as you can see here. So it's up to you however you want to do it. The program also allows you, as you can see, to assign the material properties right away. In this case, we don't have any because we didn't define them yet, but Another good thing is that the program also generates groups. So if you have the materials, then you'll be able to assign the groups into the groups right away. So here are the elements and the things that are already defined in the program. What we're going to do is we're going to first define a material, and then we're going to define some sections. We're also going to bring in a section from AutoCAD so that you don't have to define the section in midas. Everything can be brought from AutoCAD. So let's first define the materials that we're going to use. In order for you to define the materials, we go to the Properties tab, Material Properties, or you can simply right click on this option on the worksheet and we say Add Materials. As you can see here, this is a warning that the program generates. When importing from AutoCAD the XF file, the length unit must be identical with the units used in CAD. That's why I changed to feet when I first started the project. Keep that in mind. So let's add a material. Let's say that in this case we're going to use A36 steel for the cross frames. So we have an entire database. Let's just bring the ASTM and let's use the A36 from the database. Perfect. After that, let's add the concrete for the deck, and let's use a C4000 concrete, as you can see here. After you select the C4000, the program automatically activates and generates the properties of that C4000. Then let's use a dummy material, which will be the user-defined material, just to generate those transverse elements and also those longitudinal dummies. Here we can define the properties of that dummy with this modulus of elasticity, Poisson's ratio, its temperature, and so on. This obviously is going to depend on the material that you use. Let's name it dummy material, and then from there we can simply find the materials that we're going to use. After that, let's use the database to define some of the properties that we're going to use. So let's say that if we're going to use the database, the midas has a very extensive database that can show different types of sections. You can automatically generate them from different standards or codes, or you can also bring them from CAD, which is what we're gonna do with the steel composite section. Even though the program has the different types of sections, as you can see here, we're gonna follow that step so that you can have an idea of how to define it or how to bring any type of section from AutoCAD. This is just to show you the different types of sections that are available in the program. So let's go into the database and let's define an angle section from the AISC standard to define the cross frames. In this case, we're going to use an L4 by 4 by 5 16th, and we'll bring it from the database. The program automatically generates its properties, and we can hit apply. Since this is the first section that is defined, the program will automatically assign it to all the elements. This is gonna be easy to change. I'll show you after we're done. Then we define our pier cap. So let's use a solid rectangle and let's define the section for the pier cap. This section will have a user defined option, and it's gonna be a 5 by 5. We're gonna use an offset from here to center top, and we apply it. Then we define the section for the pier. The pier is gonna be a solid round section with a 6 feet diameter, and it's going to be center. it's offset, so it's gonna be, I want it to be right in the center. I hit apply. Then we're going to define the transverse dummy elements, and we're gonna use solid rectangle. Transverse dummy, and we're going to use a with the same thickness of the deck and 5 feet width. This 5 feet is the spacing between the transverse elements, just for your information. Let's define that one as well as center top. Let's just switch it here, and then we're going to have the dummy longitudinal elements that are just gonna be very small. This is just to model the moving load. And then this will be about it. We don't have the composite section yet. What we're going to do is we're gonna bring the composite section from AutoCAD. So how can we do that? As I mentioned earlier, you can bring the geometry from CAD, and we'll save a lot of time generating the model. But we also have an option in the program that is called Section Property Calculator. With the Section Property Calculator, you'll be able to define any type of section in very simple steps, and the program will automatically calculate its properties, and then you can bring it for the analysis. So in order for you to open up the section property calculator, you can just hit the tools option and use the sectional property calculator. A window like this one is gonna pop up, and let's just change the units, and then from there we're going to have something like this. What we can do is we can import a CAD with the section. My section looks like this one. Since this is a plate girder, the section of the girder is defined just by lines, and the deck is defined as the rectangle, as you can see here. We can later assign a thickness to the model, so it will be something like this. So in order for us to define the properties of the section, what we're going to do is we're gonna first define a width of those lines. So we're gonna go into the curve option, and we're gonna change its width. We can define the width. In this case, let's define the width for the top flange, and this width is gonna be 0.0625. Then for the web, and then for the, if you press the control key, you'll be able to select multiple lines and have them selected, and the bottom flange. And you have the section defined right there. I mean, just the width of each one of the curves. After that, what we're gonna do is we're going to find the materials. So we go into the model option, we go to material, and let's define the steel portion. Let's say it's modulus of elasticity. Poisson's ratio. and its density, and we hit apply, and let's define the reinforced concrete portion. We say RC, Poisson's ratio, and the unit density of 0.15. Okay, let's check the Poisson's ratio of the steel. Should be 0.3. So let's go back and change that. Perfect. It says that the material is already used, and let's just do the modification. Yes. Let me do the RC. Perfect. Let me see. We have the RC defined, and let's do the RC. Sorry, we have the steel defined, and let's do the RC option. Let's do the 0.3. Steel. Let's define its modulus of elasticity. And its unit density, and the RC. Let's define its modulus of elasticity, and we hit OK, and we have both materials defined in the model. Then we go into the model section, composite section, generate. So we assign the name to it, the number of parts that it will have. In this case, it's going to be 2, and the base material. We hit apply, and the section has been generated, as you can see. So now we're going to assign some parts into the section, model section, composite section, and add part. Let's say part 1, the girder, girder. We're gonna use line, material steel, and we're gonna use the control option. We apply. Part 2 is gonna be the deck, plane type, and the reinforced concrete material, and hit apply. This section has been defined. Now we calculate its properties. So to get the properties of the section, we're going to properties and calculate composite properties. We specify a mesh. The smaller mesh we use, a slighter increase in the calculation of the properties. Let's just select a part of it, click apply, and the program will automatically calculate the properties, as you can see here. Finally, we're gonna export it into midas civil. So in order for that to do that, we go to model section, composite section, and then we hit export. We're gonna use the composite. Let's say composite 1. We click on the section or part of it, we hit apply, and then the section has been exported. Then we go back into midas civil, into our model. Then we go into the properties section, and then here we're going to import the section from the composite tab. So we go into the composite, we hit the composite general option. We select the seg file, which is the composite one that we just generated, and here the program will automatically generate it. Let's say composite. Here are the properties for part 1, for part 2, and the total properties are right here. And then what we're gonna do is we're going to bring that section into the program. So let's change its offset, in this case to center top. We hit OK, and then we have all the sections. So in order for us to change all the properties, it will be easier if we activate the second tree menu, which is right here, and then we're going to the groups tab. Let's say for the cross frame we already have the section. For the dummy, we can assign the longitudinal dummy option, as well as its dummy material. For the pier cap, we can assign the pier cap material and section as well. So let's say the grade 4000. For the pier, same thing. By just drag and drop option, we can assign materials and properties right away. As you can see, it's a very easy process. For the girder option, we can assign the composite section, as you can see here, and the program will automatically generate the composite right there. After that, we have the dummy transverse elements, which are the transverse dummy, and these will have the dummy material as well. This is just for generating the transverse connection in between the elements. After that, what we can simply check that every element is assigned by double clicking, assigned properly, and then what we're gonna do is we're going to go into the definition of the loading and the construction staging. The program allows you to define or to consider different types of loading and construction sequences. So in order for us to define the loading, I'm gonna do like a very simple procedure for it, but in this case what we're gonna do is let's define a load group, DW for example, and let's define a load case for that. We can have different types of loading, barrier loading, the DC, the DW, the dead load, let's say DC, or self weight. It's up to you, whatever you want to define. Self weight of the bridge. So let's say if you want to apply static loads into the model, you can here go into the loads tab, static loads, and use the static load cases. Here let's define the self weight, and let's assign it into the dead load, and here we can define the dead load. We have an option in the program where you can define its self weight automatically. It's the self weight option. In this case, we're gonna assign the self weight load case and also the load group, because we're gonna use the load group for the construction staging. We assign 1 for the self weight, and there we have the self weight of the structure. Let's define also some of the distributed loads. Let's say if you want to simulate the weight of the wet concrete, we can define a load such as the construction load, or just as the, let's go into the construction stage loading. You can define it as CS load, and we have the wet concrete right here. If we want to define the distributed load for the wet concrete, we can simply select the girders and assign the wet concrete load group. Here we assign the load group for the construction sequence, and we assign its weight. That way you can have the wet concrete load in the model as well. Let's go a little bit into the boundaries. So let's define some supports. I'm gonna make it a little simple, and we will define different types of support. So let's say that for the girders, we're gonna support them at each end, and we're going to use the boundary option, define support. Here we're gonna add the support group, and we're gonna add each one of the supports that we'll be using. In this case, let's use vertical restriction or displacement, restriction on the displacement in the C axis, as you can see here. Let's also use a C and Y displacement restriction in this part, and then let's do the same for the other portion of the bridge. You can define the supports as you wish. In this case, just for the to show you how you can do that in the program. And we're gonna restrain the bottom portion of the pier, which is gonna have something like this one. After that, what we're gonna do is we're going to generate an elastic link that will connect or simulate the bearings between the pier cap and the girders. So it'll be something like this. So what we're gonna do is we're going to just activate that portion of the bridge, and then the program will show us just that part. After that, we're gonna have something like this. We activate it, we have something like this, and we're just simply going to connect here. The program is automatically asking me to save it. So what we're gonna do is we're going to simulate bearing paths using an elastic link. Here we can define its stiffness. So let's say that we're gonna have infinite stiffness, just to generate like a fixed type of connection between the substructure and the superstructure. Here we can select the nodes. Let's also assign the boundary group, and let's select the two nodes that will be connecting the, like this, substructure with the superstructure. It will be something like this, as you can see. After that, what we're going to do is we're also going to generate rigid links between the cross frames to simulate the rigid connection between the cross frames and the the longitudinal girders right here. So in order for us to do that, what we're going to do is we're gonna use the rigid link option in the program, and we're gonna start defining them in the following way. We're going to the rigid link. We're gonna also assign this into the let's say rigid link. Let's assign it into the rigid link group. In this case, let's select a master node, which will be this one right here. This one right here. And we select the slave nodes, which will be these two right here. We're gonna do a rigid body type of connection, and we're gonna copy these in the following distances. We can calculate the distances with the program, pressing the F4 or going into the query nodes, and here if we click on two nodes, the program will give us the distance between the two nodes. We can simply copy that distance, paste it, and then redo it for the last one. We copy it and paste it, and then we hit apply, and that way we can generate the rigid links. We're gonna do that for the following connections or the following cross frames, and we're gonna use the master node again here and select the two slave nodes and just hit apply. Let's do that for the following elements: master, slaves, apply, master, slaves, and apply. Master in this case, and the slave nodes, and apply. Master, slave, that way we can simulate that rigid connection between the cross frames and also the girders. We're almost done. Master, after that, what we're gonna do is and we're all set. Let's define the construction stages. In order for us to define the construction stages, we go to the load tab, construction stage, and we use the define CS option. Here we can define the construction stage, stage 1 for example. We can give it a duration, let's say 10 days. And in this case, what we're gonna do is we're gonna add the pier and the pier cap. Both of them are gonna have, let's say, 3 days of age at the activation. We're also going to assign the supports as the form, and we're gonna assign the self weight in the first step. If we hit here, stage 1, we're gonna have the pier with the supports, as you can see here. As you can see, this one has just a substructure. Let's go back into the base and let's add another construction stage. Let's say stage 2 with 10 days of duration. In this case, we're gonna add the cross frames and the girders with 0 age. We're gonna add the rigid link support as well, and we're gonna add no loads because we already have the dead load defined. If we hit OK, we're gonna have the stage 2 with the rigid links and the supports. After that, let's see how the stage 2 is. In this case, we have the links, but we don't have the supports at the piers, at the girder. I'm sorry. So what we're gonna do is we're going to assign these elements of support, these nodes, into this group. Let's assign the pier cap with the pier with the support nodes. So we copy it, this one, we paste it, and we assign those so that we can have those activated on the stage 1, which is gonna be something like this. Same thing we're gonna do for the location of the rigid links. So if we do the cross frames, for example, let's also include this portion in the cross frames so that we can have the elastic links with them, or we can simply include them as part of the pier as well. So let's use the pier and let's define that portion as well. There. We have to go into the base option, into the base. All the modifications of the model has to be done in the base. Then that way we're gonna have something like this. We have already the supports there with the elastic links on the first stage, and then we have stage 2 with the supports and everything there. If we want to add any type of loading, for example, we can add on a stage 3 in which we have any type of loading or another type of element. So let's say the dummy element, if we want to add them with a specific age, let's say 3 days, and there's another type of loading, we can also do that. After that, what I'm gonna do is I'm going to define just one moving load to show you how it is done. We have different types of loading in the program. I'm gonna use the lane load, and I'm gonna define it five feet, or let me just define it 6.5 feet from the center of that particular element. And I'm gonna use lane cross beams in order for me to do the distribute the load into the cross elements. So So I'm gonna use the group for the cross elements, which is the center group, as you might remember. And in this case, what I'm gonna do is I'm gonna select the most outer elements of my bridge, and then from there I'm going to define the moving load, or the traffic lane in this case. I can do the same for a second line. Let's say if I define it at 15.5 feet, for example, I can do the cross frames again and define it based on these 2 points as well, which will be this location. After we define the traffic lane, we can define the vehicles. In the program, we have standard vehicles. We have worked with many DOTs, and we have them available in the program. And we also have the AASHTO standards, such as the or AASHTO RFD. Let me just go into the AASHTO RFD, and let me redefine the traffic lanes. Lane 1, for example, 6 feet, cross frames, apply lane 2, 15.5, and redefine cross beam with the 2 elements. And there you go. Now we have the vehicle definition. As I mentioned, we have many types of vehicles available for the, in this case, AASHTO RFD. We have also worked with many DOTs, and we have the vehicles loaded into the program. In this case, I'm just gonna have the HL93, and then I'm gonna use a moving load case that will have the multiple presence factor, and we'll have the minimum and maximum number of loaded lanes. We hit OK, and that way, if we check, we have each construction stage, and then from there we can run the model. Let's just run it. Then after we finished, I'm not gonna go over in detail into the analysis portion. When we're done with this model, we can simply export it to CAD in order for us to show, let's say you want to present a project and you need a rendering of the model, and you don't have, let's say you don't want to use midas as the rendering. You can just simply display it using CAD functions, such as the ones that I'm gonna show you now, in which you can export this model to CAD, either to centerline or to the entire hidden or render option, and then you'll be able to have something like this where you have the 3D model. You can present it, the overall model information, without using Midas Civil to the clients, or just for displaying purposes or discussions. You'll be able to generate a rendering like this one and export it into AutoCAD. So let me just go back to the model, and we use the export function, export AutoCAD DXF, all the elements, centerline and shape. So that way you can simply export it, composite model like this one, and then you can bring that composite model into the AutoCAD. So let's just open that composite model that we just created, and you're gonna have something like this, a 3D rendering of the section and the bridge that we have just created. As you can see here, this is very useful for showing the different parts of the bridge or displaying the different portions, or if you want to present a 3D view of it without using Midas Civil, you can also do it as well in the program. I hope that you guys could use this CAD to CAD function in order for you to generate the entire bridge without having to model it in the program. You, as I mentioned, can bring the DXF file as you saw in the video, in the webinar, I'm sorry, and as you saw in the session, and then you can simply generate your model with simple steps, generating the sections, importing from CAD the section as well, generating the different loads, all that without having to, you know, going to model member by member manually. Thank you all for your attention. If you have any questions, please ask or send us the ticket into the global support.midasusers.com. This is our global platform for technical support. My name is Edgar de los Santos. I hope you have a very good day. Bye bye. Thanks again.